In this video, I will go through several problems where we evaluate expressions with the distributive property. And the key thing is to always take the number on the outside of the parentheses and multiply it by every single value on the inside of the parentheses. And so in this case, there's two values inside. So we're going to first do 6 times 4p, and then we'll do 6 times 8. And you see that written down here. You're going to multiply the 6 by each of those terms. And then this next term doesn't look like it has a number there. So anytime it's just a minus, you can think of it as minus 1 times what is in the parentheses. And we usually, in math, just don't write the 1 because when you're multiplying by 1, it doesn't change the value. So it's just a little quicker and more convenient to leave the 1 off, but that's the number on the outside of the parentheses. So you're going to be doing minus 1 times p, which is just a negative p, and minus 1 times 3, which is a negative 3. So just like we did here with the 6, we multiply it by both terms. We do that negative 1 and multiply it by both the terms. And so now let's actually do that multiplication. 6 times 4 is 24. 6 times 8 is 48. And we've already just done minus 1 times each of those terms in the second parentheses. So combine what is the like terms. So the terms with a p can be combined. There's 24 of them, and we're taking 1 away, so we have 23 total. And then the numbers can be combined. So you have 48, and you're minusing 3, so you have 45 total. And then this would be your final solution. In this next example, we're going to be doing the same thing, distributing the number on the outside through every term inside the parentheses. This time we have fractions, but we're going to take the 2/3 times that first term and the 2/3 times the second term. And in the next parentheses, we do that same thing. So that's written out down here where we haven't actually done the multiplication yet, but we're showing the number on the outside multiplied by each value on the inside. And then so we need to actually do the multiplication. If you think about how multiplication of fractions works, when we have a whole number, like just 7 here, it can be helpful to write it as a fraction. And anytime it's just a whole number, to make it a fraction, you just put a 1 on the bottom. 7 divided by 1 is equal to 7. So this is the same way as writing 7. It's just written as a fraction. And to do the fraction multiplication, you do top times top and bottom times bottom. So 2 times 7 would be 14, and 3 times 1 would be 3. So that's what we get for that first term. And then we're doing that 2/3 times the 6 is the second term in that parentheses. So 2 times 6 is 12, and 3 times 1 is 3. Now, if you have 12 over 3, 12 divided by 3, you can reduce that. Always try to reduce your fractions as much as you can. So 12 over 3 is the same as 4, so that's why we just get 4 for our second term. So doing that same thing, I'll go ahead and write them out just so we can see the fractions all written out. With our second set of parentheses, we have 1/3 times 2 over 1. So you're going to get 2 on top and 3 on bottom. 3 times 1 on bottom, 2 times 1 on top. So you get 2/3 z. And then you're going to have 1/3 times 9 over 1. So you get 9 on top, and 3 times 1 is 3 on bottom. Well, 9 divided by 3 reduces down to just 3. And so now that we have done that multiplication, we want to simplify and combine like terms. Adding fractions together, we need to make sure they have the same denominator, which in this case they do. And so then we just add up the numerators. If we had 14/3 plus 2/3, that's a total of 16/3, and that's multiplied by z. And then we had a 4 plus 3, and that gives us 7, and so that is our final solution. For this next example, we actually have 2 sets of parentheses or brackets here. And so we want to start with the innermost one first. That's always what we want to do when there are, nested multiple sets of parentheses or brackets. Now, we could distribute this 8 through and do 8 times 5 and 8 times 2. That would give us 40. 8 times 5 minus 16, which gives us then 24. So you can use the distributive property there. You can also just reduce the parentheses as much as possible first, which we can actually do 5 minus 2 and get 3. So then we just have 8 times 3, which is again 24. So either way you do it, you should end up right here where that 8 multiplied by the parentheses part is equal to 24. So now that you have that, you again have options. You could do 8 times 7 and get 56, minus 8 times 24, which I would need a calculator for that. And using my calculator, 8 times 24 comes out to 192. And I meant to write a plus there, so you get 56 plus 192, which is, if you add those two things together, you get 248, and that's your final solution. But again, you don't have to use the distributive property if it's possible to combine everything inside of the parentheses into a single number, which you can do. 7 plus 24 is equal to 31. So now you can just do 8 times 31 on a calculator, and that gives you the same result of 248. For this next problem, just one more example of using the distributive property to solve. You're first going to take the 11 times every term inside of the parentheses. So 11 times 3 is 33x. 11 times 3x. And 11 times 2 is 22. And then you take that number outside the second parentheses, which we can look at that as a negative 3 and minus 3. And you're going to multiply that by x, which gives you minus 3 times x. And the negative 3 times the 1 would be negative 3. And once you've done distribution of both those parentheses, you can now combine the like terms. So 33x minus 3x gives you 30x. And the numbers then 22 minus 3 gives you the 19. And that's your final answer. So to distinguish this from the previous problem, we have to use the distributive property here to get this reduced and simplified, because there's no way to combine the numbers and the terms inside the parentheses into a single number. 3x plus 2 cannot be combined because the first term has x in it, the next one doesn't. The same with the second parentheses. So we're stuck with having multiple terms inside the parentheses. So if we want to simplify, we have to use the distributive property.